Modulus of y plus 3x is equal to 0 and modulus of 2x plus 3 is equal to modulus of x minus 5, where x, y are real numbers. What is the value of x for which a valid solution exists? This is a problem that involves equations with modulus. So the variables are not like that in a regular equation, but they have basically modulus. So that's where these kind of problems may be a little bit more challenging than just solving regular equation problems. They're not particularly hard though. If you know the correct way to approach these problems, they're actually quite easy. So this is not the hardest of problems, but students and test takers often find this challenging because they are not just your regular equations and involve the modulus. So you have to know how to deal with the modulus operation or the modulus, the variables with the modulus sign in order to solve these problems correctly. So I'll try to show the best approach to solving these problems, but let's start with a quick refresher of what the modulus sign means. So modulus of a variable z or a quantity z will be equal to z if z is greater than or equal to 0, meaning if z is non-negative, then it's just equal to z. If z is less than 0, then modulus will be equal to minus z. So essentially, if you have those two bars and a variable inside, then the value of that becomes equal to the magnitude. So we won't be paying any attention to the sign. So especially if the sign is negative, we'll ignore the sign and just take the magnitude. So that's what the modulus sign means. It's actually quite simple. So we have this equation, and there are two equations that are given, and we start with the second equation because it just involves the variable x. There is, of course, modulus signs which we'll have to take care of, and this will be the way to approach it. So what we'll do is we'll first determine the cases when the modulus or the variables within the modulus on either side of the equation are positive or negative. So we'll have to, of course, consider different combinations because we have basically two different quantities within the modulus on either side of the equation. So on one hand, we have 2x plus 3. On the other hand, we have x minus 5. So we start by first considering the variable within the modulus on the left-hand side, which is 2x plus 3. And let's consider that 2x plus 3 is greater than or equal to 0. So when will this be true? So we can easily derive that this will be true if x is greater than or equal to negative 3 by 2. And then we consider what about if the variable within the modulus on the right hand side, which is x minus 5, is greater than or equal to 0. Well, this is true if x is greater than or equal to 5. So when will these two simultaneously be greater than or equal to 0? So for that to hold, we can basically take the stricter of the two criteria, which in this case is x greater than or equal to 5. Because if x is greater than or equal to 5, then that automatically implies that x will be greater than or equal to negative 3 by 2. So for this, if x is greater than or equal to 5, then we know that the quantity within the modulus on both sides are positive. So we have the equation, we can write the equation simply as 2x plus 3 is equal to x minus 5, because under these set of values, with these set of values of x, modulus of 2x plus 3 will be 2x plus 3 because 2x plus 3 is greater than or equal to 0. And the same thing for modulus of x minus 5. Now we can just treat this as a simple equation and solve it. This is what we get. We get x is equal to minus 8. Now, if it were just a regular equation, this would have been a perfectly good solution. But remember, this is not a regular equation. We have a modulus sign, and we took variables out of the modulus sign, and in order to do that, we have already constrained the range of values of that variable. So in this case, we have constrained, our requirement is that the variable needs to be greater than equal to 5. But the solution that we come up by solving this simple equation is x is equal to -8. Now, that doesn't really satisfy the range of values of x for which we could write this equation, right? Because that range has to be, x has to be greater than equal to 5 for that range. So x equal to -8 is therefore not a valid solution. So we simply ignore that. So next, consider the case when 2x plus 3 is greater than equal to 0. So it's the same as above. So we have x is greater than equal to -3/2. And we have x minus 5 less than 0, which implies that x has to be less than 5. And if we combine these two, for these two inequalities to hold true simultaneously, we basically have to have x to lie between -3/2 and 5. And if that's the case, then the modulus on the left-hand side of our equation, which is modulus of 2x plus 3, will be equal to 2x plus 3, and the modulus on the right-hand side of the equation, which is modulus of x minus 5, will be equal to negative, and within parentheses with x minus 5. Why? Because we know that modulus of z is equal to minus z if z is less than 0. And in this case, for these range of values of x minus 5 is less than 0. So modulus of x minus 5 will be negative, and within parentheses we have x minus 5. So 2x plus 3 is equal to negative within parentheses x minus 5. It's simple to solve this equation, and this is what we get. 3x is equal to 2, implying x is equal to 2/3. And this is a value that satisfies the range of values for which we have basically solved this particular equation. So 2/3 lies between -3/2 and 5. So this is considered to be a valid solution, at least for now, for the range of values of x for which we have solved. So remember, for now we're just focusing on the second equation, because we're given an equation in two variables, y and x, and the second equation has modulus signs, but it has only got one variable x, and that's what we have started with so far. So far from what we have, this seems to be a valid solution. Now, what are the other sets of possibilities with 2x plus 3 and x minus 5? Well, 2x plus 3 can be less than 0. So far the possibilities we considered had 2x plus 3 greater than equal to 0. So now we're considering the possibility that 2x plus 3 might be less than 0 and x minus 5 is less than 0. And that implies that x has to be less than -3/2 and x has to be less than 5. And if we again combine these two, the stricter the two criteria is basically x has to be less than -3/2. Why? Because if x is less than -3/2, then automatically x has to be less than 5. So under these set of values of x, we basically have the modulus equation be written as, so we have modulus of 2x plus 3 is equal to negative, within parentheses we have 2x plus 3, because 2x plus 3 is now less than 0, right, for these set of values of x. And similarly, on the right hand side, modulus of x minus 5 becomes negative, and within parentheses we have x minus 5, because x minus 5 is also less than 0 for these range of values of x. And now again we treat this as an equation. This will be actually in effect similar to the very first one that we solved. So we are basically getting the same value of x, -8, but this time the value of x that we find by solving this equation is actually in range. So x is equal to -8 means that x is less than -3/2, which is the range of x for which we had this relationship satisfied, right? So we are getting a value of x that is in range, so that's good. So this will be also a valid solution. So now there can be a fourth possibility, or we can consider whether this is a possibility or not. And let's look at that. What's the fourth possibility? We can have 2x plus 3 less than 0 and x minus 5 greater than equal to 0. But does it really make sense? Can it really happen? Well, for 2x plus 3 to be less than 0, x needs to be less than -3/2. And for x minus 5 to be greater than equal to 0, x needs to be greater than equal to 5. And these two taken together doesn't make any sense, because if x is less than -3/2, it can't be possibly greater than equal to 5. So this is actually not a possibility. So we just cross that out. So now that we have got two potential values of x, we need to pay attention to the very first equation, which also involves the variable y. And according to that equation, modulus of y is equal to -3x, right? We just take 3x to the other side, so we have -3x, and that's what we end up with. Now we need to plug in the two values of x that we got, right? So if x is equal to 2/3, then modulus of y is -2. Now modulus by definition means that we are considering the magnitude of the quantity. So the modulus of a quantity cannot be negative. So this doesn't seem to be a valid option or a valid solution, right? Because if x is 2/3, the value of modulus y that we're getting is a negative number, which makes this particular set of solution, or this particular solution of x, inadmissible. Now what about x is equal to -8? So we plug that in, and now we have modulus of y is equal to 24. It's a non-negative number, and that's what we need a modulus of the variable to be, right? Because it's non-negative. It cannot be negative. And so this one seems to be valid. So the value of x for which a valid solution exists to the given pair of equations will be x is equal to -8.